Video 3-6 can be found as worksheet number 3 on Blackboard. It has an interesting name, Penetrating Insight. What we're going to do is try to determine the extent to which a box and whisker plot may be drawn from the 5-number summary only. The data is unknown. In the previous worksheet, we had the data and we made our own 5-number summary, but this time we do not have the data. We know that 8 is in the data, that's the minimum of the data, and we know that 60 is in the data, and that is the maximum of the data, but those are the only pieces of data that we know. The rest of the data is unknown. And so let's go through this question and see how we can do in drawing the box and whisker plot. We know the box starts at Q1. Q1 is 20. The box starts at 20, and it goes to Q3. Q3 is 40. And so the box begins at the first quartile, 20, and extends to the third quartile, 40. There's our box, and the median is at 28. We put a line in the box to show the median. And all that is left is the whiskers. We must complete the box and whisker plot by including the whiskers. Now the whiskers cannot go all the way to the maximum and all the way to the minimum if they are too long. So how do we know if they are too long? We must compute the interquartile range. That's the third quartile. Subtract the first quartile. 40 minus 20 is the computation, and we get 20. The interquartile range is 20. And the maximum length of a whisker, the maximum length of a whisker is 1.5 times the interquartile range. In this case, that's 1.5 times 20. The maximum length of a whisker is therefore 30 units. And rather than trying to memorize the formulas for the lower fence and the upper fence, it is possibly better to use the box and whisker plot to help you. So the lower fence is somewhere below the first quartile. The left-hand whisker can extend no farther than the lower fence. The left-hand whisker would start at Q1. The left-hand whisker would start at Q1, and it can be 1.5 times the interquartile range in length. And so the first quartile is 20 minus 1.5 times the interquartile range, that's 30. We get minus 10. The lower fence is a negative number. The minimum is 8. We'll put a dot where the minimum is. It is inside the fence, and so the whisker goes to the minimum. The right-hand whisker. The right-hand whisker starts at Q3, and it cannot go beyond the upper fence. Where is the upper fence? The right-hand whisker starts at Q3, and this time we can add 1.5 times the interquartile range. The third quartile is 40. The maximum length of a whisker is 30. 40 plus 30 brings us to 70. The upper fence would be at 70. The maximum of the data is at 60. That's a value that is also inside the fence, and so the whisker can extend to the maximum. Both the left-hand whisker and the right-hand whisker we can draw because there are not any outliers. All values of the data, all values are inside the fences. The minimum of the data is 8, and that's inside the lower fence. The maximum of the data is 60, and that's inside the upper fence. There's nothing missing from the box and whisker plot. So we can draw the complete box and whiskers plot. So what about the case in question number 2? Many of the statistics are the same. The minimum is the same. The minimum is a piece of the data. That's one piece we know. This time the maximum has changed. The data goes up to 90. The rest of the data is unknown, but the first quartile is the same as before. The median is the same as before. The third quartile is the same as before. Therefore, the interquartile range, Q3 minus Q1, it's the same as before, 40 minus 20. The first quartile minus 1.5, the interquartile range is exactly the same calculation as before. The lower fence will be at minus 10. Again, the upper fence will be at 70. So those calculations will be exactly the same. The lower fence is at minus 10. The upper fence is at 70. I've repeated the 5-number summary. And the next question is, are there any outliers? Well, let's start drawing the box and whisker plot. Again, the first quartile at 20, the third quartile at 40. We can begin the box and whisker plot by drawing the box as always. The median, once again, 28. The minimum, again, is 8. That's inside the fence. The lower fence is at minus 10. Remember, a negative number, the lower fence is way out here. The minimum is inside. The left-hand whisker is okay. The maximum this time is at 90. I'll put a dot at 90. And the upper fence is at 70. And so 90 is outside the fence. The value of 90 is an outlier. The maximum of the data is 90, is an outlier. It is outside the fence. Now, can we determine from this information all possible outliers? Well, remember, all we know about the data, the smallest number is 8 and the largest number is 90. What if there is 80 in the data? If 80 was in the data, that would also be outside the fence. So we would have another outlier. But we don't know the rest of this data. And so can we determine from this information all possible outliers? No. We need to know the large values. We need to know if there are more values outside of the fence, larger than 70. Need to know if more values in the data are larger than 70. So, can we draw the box whisker plot from the 5-number summary only? And the answer is no, we are missing a whisker. So, the right-hand whisker is missing. We do not know where the whisker will end. And it is possible that there are more outliers. So we might have two things missing. The right-hand whisker is certainly missing, but maybe we have more outliers. So we need additional information. And in part E, it says, what if? What if you were told that the largest 3 numbers in the data were 66, 78, and 90? So that means that we would know the smallest data was 8, And then the largest three values were 66, 78, and 90. We would know four values in the data. Would this be enough? Well, 90 is the maximum, we've marked it. 78 is outside the fence. That would be another outlier. 66, these are the three largest values, 66, 78, 90. So the next piece of data is actually inside the fence at 66, and that is where, therefore, the whisker would stop, the right-hand whisker. And so if we knew that the three largest values of the data were 66, 78, and 90, could you add the missing pieces of the plot then? We just did. And we finished the plot. Does this now tell you all of the outliers? Yes. 78 and 90. 78 and 90. We have two outliers. Here's another what if. We have finished the box and whisker plot. We've finished the plot, we know the outliers. What if the largest three numbers, instead of being 66, 78, and 90, what if they were 40, 78, and 90? So then we would know four values in the data. We would know the minimum was 8. We would know 40, 78, and 90. 90 was as before, the maximum. 78 was that before, another number outside the fence. And 40 would be the next highest number. And that's where the whisker would end because 40 is inside the fence. But where exactly is 40? 40 is also the third quartile. And so not only would the right-hand whisker start at 40, it would also end at 40. In other words, there really wouldn't be a right-hand whisker. The right-hand whisker in this case would end at 40. It would both start and end at 40. So that's an interesting little what if. If these were the largest three values in the data, we actually would not have a right-hand whisker. We would know that 40 was in the data, however, and we don't necessarily know that 40 is in the data. The third quartile is not necessarily a data item. So in summary, in conclusion, we can draw the complete box and whisker plot from the 5-number summary if there are no outliers, as we did in part 1. In part 1, we completed the box and whisker plot. There were no outliers. In part 2, there was an outlier. The maximum was an outlier, and that meant that we needed more data to complete the plot.